Okay, 1.7 day 1 inverse functions and testing to see if they are if a function is 1 to 1. If 2 is in the domain of f of x, and 5 is in the range of f of x, then that means f of x, if you put 2 into f of x, it gives you 5, and if you put 5 into the inverse of f, it takes you back to 2. So that's one way we can think of inverse functions. And we could think of whatever f does to 2, the inverse of f cancels what was done and takes you back to 2. So this looks like in a table we would see x, f of x, and we know that we put a 2 in and we got a 5 out, but the inverse, the table of the inverse would put a 5 in and get a 2 out. So there we see we're switching the x and y values, and then this appears in a graph. So the point is there. That's the graph of f of x. Here's the graph of the inverse, 1, 2, 3, 4, 5. And they are symmetric to the line y equals x. So this point reflects down here. It would appear down here, and that would be that point. This point reflects up there, and that would be that point. So we see a symmetry to y equals x. There's another, that's the graphical characteristic of inverse functions. All right, so let's look at the graph of f. And let's also look at the table. And then we can just see, we saw already that if we switch the x and the y, so the y value here becomes the x value in the inverse. The x value in the function is the y value in the inverse, and then that will tell us what the inverse graph, the graph of the inverse will be. We can just plot these points, negative 4, negative 2, 1, negative 1. All right, and then the question is this a function? And we see that it fails the vertical line test. Not a function. Okay, when the inverse is not a function, then we say that the original function is not one-to-one. So this is not a function, therefore f of x is not one-to-one. That's the name. If it is one-to-one, if this is one-to-one, then this passes the vertical line test. All right. The vertical line test on the inverse is the same as the horizontal line test on the function. So horizontal line test is probably new to you, but we can see that Alright, so we see that it has an inverse, but it's not a function. So this is the horizontal line test, shows whether the function that you start with has an inverse function. We see that it has an inverse, but the inverse is not a function in this case. And shows whether a function has an inverse, and this means a function has an inverse function. This means the same as the function is one-to-one. So, to say that a function has an inverse function is the same as saying the function is one-to-one. Alright, pause and try this one on your own. If you need a hint to graph it, find the x-intercepts and the y-intercept. That should get you started and you can draw the graph. And if you don't see how this was done, you can do it like this. Multiply to get 64, add to get negative 16. So negative 8 times negative 8 is 64, and I add to get negative 16. That's how we can get that. And we'll have x minus 8 squared. If you do the square root, you still have x minus 8, and then you get x equals 8 for the x-intercept, and we also have the y-intercept. The y is 64, so we just know that the 60, just say 64 there, and then we're going to go out to 8, and that's where the x-intercept is. Because of this being squared, we know there's only one x-intercept, so it's not going to curve down and have another x-intercept. That's the only x-intercept, so it must be the vertex. And then we can just use symmetry to draw a sketch. And we want to know if the function is one-to-one, so we do the horizontal line test. The horizontal line touches more than once, so f of x is not 1 to 1, which means f of x does not have an inverse function. It has an inverse, but the inverse is not a function. All right. So pause, draw these graphs, and do the horizontal line test. Slope 3, y-intercept -8, 1, 2, 3 over 1. So it passes the horizontal line test, so it is 1, 2, 1. Y equals 4, horizontal line touches infinite times, so it is not 1, 2, 1. Okay, this is going to have a, it's rational, and it got shifted to the left too. So we'll have a graph like that. If we plug in a 0 for the y-intercept, we know the y-intercept is 4. And something like that. Horizontal line, every time you draw a horizontal line, it touches once. Every horizontal line touches once. This is an asymptote, so the horizontal line on the x-axis does not touch the graph, so it passes the horizontal line test. It's 1 to 1. And we have a radical, and the 4 is an inside change. That's a horizontal dilation. We would divide all the x values by 4. That means it's going to compress horizontally. So here's a review of dilations. If this is the parent function, and then we divide all the x values by 4, here's the value, x value of 4. Well, now it's going to occur at 1. And then this is going to occur at 1/4, so we just get the graph doing that. But it does pass the horizontal line test, so it's 1 to 1. And we've been showing that functions are 1 to 1 graphically. Now let's verify that two functions are inverses algebraically. All right, so to show that, when we do f of g, they have to cancel. F has to cancel g, and then we'll be left with x. And then we do g of f, and they have to cancel also. So f of g is going to be f of g, and the 4's cancel, x minus 9 plus 9, and we get x. So then we'll do g of f, and we copy g, leave a space, and put in f. Therefore, f and g are inverses. All right, you do the same for this one, and this just means that we're only going to put in 0 or positive numbers here. So pause it and try that one. If we're doing f of g, we leave a space. So f cancels g. Copy g. In place of x, we'll put f. And distribute the 4. And since x had to be positive, we know that this is always going to be positive, even though you could have a negative or a positive in there. This is always positive because it said so in the beginning. All right, and try another one. And you show whether f and g are inverses. Pause and try it on your own. And with this exponent rule, we just multiply and we'll get x. So now we copy g, and put in f. Alright, and that is the end of this lesson.